Yeah, I am going to talk a little bit about the thing that sits here and my own software and stuff, but like I said this morning, I've been asked to do something different. I'm not the best human beatboxer in the world, as you can imagine, otherwise I wouldn't be a software developer anymore, because human beatboxing is just so much more fun. But if you're interested in how this works and what you can do yourself, you can follow along. So this is going to be like a very simple explanation. I'm going to show 3 fundamental sounds of human beatboxing. The first one is the bass drum. It goes a little bit like this. This is not, it could be a little bit louder, but that's probably fine. And if you want to follow along, you want to try this yourself, you should probably stand up because it's kind of hard to beatbox while sitting. So if you want to do that, nice. And so there are 2 fundamental ways how you can do a bass drum, and it's basically 2 different types of sounds you can make. The first one is a little bit like. Try that. Yeah. And it sounds unimpressive, but that's because you don't have a microphone. Like a lot of human beatboxing relies on the fact that you have a microphone and the microphone responds in a specific way to the sound waves that your lips make. And it sounds dull, like that sounds like nothing, but if you have a microphone, it will sound more impressive. And the other one is actually a D, so you could do something like dum, dum, dum. Dum, 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 dum. And at some point you need to start breathing and then things go wrong. That's totally normal for beginners as well. The next one is a snare, clap, rimshot kind of thing. And the original human beatbox people mostly did like a pff, pff. And it's like pff, pff, pff. And it sounds a little bit like a synthesized snare of sorts. And try that again. Now, the interesting thing is, if you get into the breathing rhythm thing, you actually need to learn how to do this backwards. So by not pushing out air, but to breathe air in. And this is, I'm not really good at this, so you don't need to try this because it's hard. It goes a little something like this. And I'm breathing in air while I'm doing that. So it helps with the breathing rhythm. Now, the second one is a clap is really hard to do with a mouth. It's easier to just clap, and that's because a clap is usually a couple of impulses that come like in random order. Like if you see how drum synthesizers synthesize claps, it's relatively complicated. And so what you can do is a rimshot, which is the sound when the drummer hits the rim of the snare drum, so the outer rim, and it's a very harsh sound, so like, and it's really just And that one you can also do backwards. And now we have 2 sounds. And that's already something, right? And the last one is the hi-hat cymbal. And that's really easy. It's really just. Yeah, that sounds right. So. If you want to turn this into a simple rhythm, there's a really nice way to say that, which is just boots, cats, boots, cats, boots, cats. And like I said, I really suck at this. So here's a couple of names to Google of people who can do it really, really well. Just look at YouTube and look at these people doing things so much better than what I can do here. Cool. Nice. Okay, so why am I doing this? So last year's JSUnconf EU in Berlin was really special for me because I participated in the call for artists, and I've been doing weird stuff at JSUnconf EU for a while. I, for some reason, even opened up JSUnconf once with another musician, doing my live coding stuff that I was doing back in the time. And last year we did music during the breaks, we did the introduction, we did a lot of things, and after the conference ended, I was invited to join Live.js, which is sort of a music group collective of audiovisual artists. And you can find out more at livejs.network. There's also a Live.js Slack if you're interested in audiovisual stuff. It's a very helpful, like it's an open Slack, very helpful people with all kinds of info on like modern WebGL, visualization stuff, web MIDI, web audio, all of that stuff. Yeah, this is a picture from like a screen grab from a YouTube video that exists. This is me in the front there. And we were doing the introduction of last year's JSUnconf EU, and that was, I can tell you, that was nerve-wracking. It was a lot of fun too. So this is most of Live.js in one picture there. Our current lineup, Ruth, Tim, Martin, who was here yesterday, I don't see him today, Sam, Matt is our New Zealand representative, which sometimes makes travel a little harder than it should be. Yeah, and like I said, I joined last. Like I said, we played at a couple of conferences, JSUnconf EU. We're going to play JSUnconf Asia this year, which makes me super happy, and also a bit anxious because I'm flying to Singapore. We played at .js last year, we played at Coldfront I think 2 years ago, we played at Ruhr.js, which was a lot of fun. Great conference. Maybe we're going to do something again, could be. And yeah, so I needed to come up with a tool that allows me to quickly improvise music with my synthesizers in my computer. And I was doing, like I said, I was doing music live coding before, which was fun, but also way too slow. I'm a bad, slow coder. I'm not very good at memorizing all the shortcuts. And I wanted to have something that was a little bit more intuitive and quick for me. And I wanted to build this tool which would have a couple of features. Quick workflows means that I don't need to kind of go through a lot of menus to do stuff. It needs to be all kind of at a button press. It should be pattern-based, which is, if you know more about music, it probably makes sense to you. If not, patterns are basically very small pieces of music that you repeat over and over again, and that makes it really easy to build more complex stuff out of them. It should fully utilize the Ableton push, which is this weird thing sitting at the side here. I'm going to hold it up in a second. And ideally, I wanted to have it so that I don't need to look at a different screen. I don't want it to look at the computer screen, because it's easy to get lost in a computer screen. And like if you need to start like moving your mouse around, especially on a touch pad or something, you're already lost in terms of speed. I wanted it to be built with web technologies, mostly because the whole thing is called Live.js and not Live C++ or Live Rust. Even though Matt does have a performance system that is built on Rust, but I mean, he also did awesome stuff in JavaScript, so I think that still counts. And I didn't really want to have a huge build pipeline, but that's just me. I don't like to fiddle around with Webpacker and whatnot. And you know, with modern web technology, so to speak, you can actually do things like use JavaScript modules without having a build pipeline, which is pretty cool. The Ableton Push 2 from the top looks like this. It's a controller that has been purpose-built for a music software. You're going to see the music software in a second as well. but this is very special hardware for that very special purpose. But fortunately, Ableton was kind enough to completely open up the specification of this thing. And even though it has lots of buttons that are labeled in very specific Ableton ways, you can kind of use them to your own avail. And it has this awesome collection of 64 buttons in the middle, which are velocity sensitive, so you can play them lighter and harder and get different sounds out of it. Lots of encoders on the top, which is a fancy name for knobs that you can turn endlessly, and lots of buttons as well. And yeah, there's also a touch strip, which is interesting. So it's this piece of plastic, and you can slide your fingers across and get different values depending on where your finger sits. Lots of LEDs. Every button has an LED below it, so you can turn it on, turn it off. I don't know, something like 60% or so are RGB LEDs, so you can turn them into different colors as well, which is cool. The other half is just white LEDs. And it has a display, and we're going to see that this is interesting because, well, with the buttons, pads, encoders, and touch strips and LEDs, you can actually, like, all the input elements just send MIDI. I'm going to talk about MIDI in a second, but it's a really simple protocol that is easy to understand, easy to work with. And the LEDs, on the other hand, you just send MIDI data to the device, and it's going to display different colors depending on the values. The display is too big and too high resolution that you could do something with MIDI there, so we need to figure out what's going on there. This is the official description. So you connect the whole thing via USB, and USB is a so-called composite device with a MIDI interface and a generic bulk data interface used to drive the display. That sounds fancy, right? Generic bulk data interface. What? So USB. USB can do, as we know, many things. It's called Universal Serial Bus for a reason. So you can have storage devices, you can have so-called human interface devices, as we heard in the talk from Ramon earlier yesterday. So human interface devices are keyboard, mice, game controllers, whatever. And then you have things like audio, so you can connect something that is an audio card and listen to some music. You can do MIDI, quite surprisingly, and lots of other stuff, and then you can also do generic data, aka vendor-specific crap. MIDI, like I said, is a very simple protocol. The original MIDI specification is from 1983. Who in here is born after 1983? Interesting. I mean, that sounds like I'm trying to brag up here, but to be honest, like in 1983, I wasn't thinking about like doing stuff with computers and synthesizers, so to be fair. Because it's such an old standard, it's a basic serial protocol. For the most part, in modern APIs, it's encapsulated in a way that you don't have to parse out the data yourself. So, for example, from Web MIDI, you will get something like this, which is 3 bytes that probably don't mean too much to you. So there's no like high-level tagging or anything. It's just you. I mean, I'm looking at this now and I know exactly what it does, but that's because I've been breathing this stuff for far too long, and my brain is mushed with MIDI. But let's take a look. So this is actually a command that, for example, a keyboard would send if you press down a key. So the first command is, the first byte is a command byte, and you can tell that because the 8th bit of that byte is set. You've seen that, right? So, I mean, the value is over 127, basically. So, yeah. Every other thing you're sending, like every data byte you're sending is only like with the 8th bit not set, so it's going to be below 127, which also means that for most things you can only send like 127 distinct values, which is barely enough for the note, which is the 2nd byte. Oh yeah, and the other thing, So in the upper 4 bits of a command byte encode the actual command, and the lower 4 bits encode the channel. So there's 16 channels you can send data on, which was more interesting when there were like only like one cable connection. Nowadays, like every synthesizer has its own USB connection and turns up as their own MIDI device, and so it's not that needed anymore. But anyway, you have 16 channels. Yeah, and the next one is the note, and the note is a MIDI note number corresponds to a note in the standard 12-tone system that we have in Western music. So 0 would be a very, very low C, and a 36, because it's 12, 24, 36 values above that is also a C, because every 12 values you get the C again. And then like a 1 would be a C sharp, 2 would be a D, and so on. So if you know a little bit about music, it makes sense to you. If not, I'm sorry, I guess. And the last value is the velocity, and that's just how hard I hit the key. So 100 is pretty hard given that we have 127 values. If I play it, like if I touch it really lightly, it will be a lower value. And so you can send this byte sequence to a synthesizer and it will start playing a sound. Now, the problem with this is, depending on the synthesizer, it might never stop playing that sound because that's a different command. So you would send 128 to actually switch off the sound. That's one of the things you learn quite early when you're playing around with MIDI, because suddenly you have this cacophony of sounds that coming from your synthesizer and you have no idea why. So that's MIDI. Let's talk about the generic bulk data interface. And this was a fun little experiment. So this is all from, like, most of it is from the documentation from Ableton. So what you do is you have this generic bulk data interface and you use a library called libusb, which there's a node module for it. And so you're sending, you just send bytes to it basically, almost like a serial interface, I mean, which is not surprising, USB, Universal Serial Bus, so yeah, makes sense. And so you send it a frame header, which is just a thing that tells the device, oh, there's some data incoming, I should take a look at it, and it's just the same 16 bytes every time. Yeah. And then you send the frame buffer, which is, you know, data to display on the display, and then you do that all over again. You do that 60 times per second, so you get 60 frames per second. If you don't send any data, the device will cache it for about 2 seconds or so, and then the display would turn black. The frame buffer data is organized in a slightly weird way. You have 16-bit per pixel, so it's not like your usual 24-bit thing. It's a little bit less resolution in there, makes it a little easier to send raw data over. And it's packed in a kind of weird way, so you have something like 5 bits for blue, and then 6 bits for green, and then 5 bits for red, and that probably makes sense for some weird color psychology, no, color physical reason, whatever, I have no idea, but that's how it works. It's little endian, that's something you need to know when you're sending data that is bigger than bytes. And for reasons that I do not completely understand, but I think have to do with signal transfer over the actual wire, you need to XOR it with a specific value for signal shaping. I think it's just to prevent things like 0000 from happening on the data bus, because that would be bad for the signal quality, I think. So yeah, so we now know what kind of data we need to send to it, but where do we get them from? And I mean, we're on a web conference, web-related conference at least, and so what would be easier than using Canvas? So if you have a canvas of a certain size, why does that, there you go. Okay, so if you have something like a canvas that is 960 by 160, you can do something like context get image data, and you will get actual raw pixel data from the canvas, which is really cool. You have to know in which way they are organized, and as you will note, it's kind of weird because we seem to have 4 bytes in there, but I only need 3 of them. What's going on here? Yeah, the 4th byte is actually transparency, but I just discard that because I just show you. Like, there's no hole in it, so transparency doesn't make any sense. Anyway. Well, okay, so we have an interesting setup where we actually can use web technologies to generate the display data, but now we have to send it over something like libUSB, which is a node module, which you can't because it does have native dependencies on libUSB, which is a C library. You can't just load it up in your browser. That doesn't make any sense. There is a thing called WebUSB. Has anyone in here ever used WebUSB? The thing is, it needs to be supported by the hardware. There's a specific amendment of the USB spec, and I don't think the Ableton push does that. So what you can do is just use something like Electron, and then you can require a module with native dependencies in your web view. That sounds scary to me, but it works. So yeah, I'm just initializing the device and then send the frame out. And that's all. So that's how you end up with a display. And, nice. And you can actually see things on the screen. And it actually works quite well. It's pretty responsive, and yeah, like I said, this is all drawn on a canvas, as I can show you because I have this whole thing here. And now if I turn this knob, you can actually see that also being represented in the canvas element up here, which is quite cool. I have a couple of extra slides. I'm running a little bit out of time, so I really wanted to talk a little bit more about this. So why? This is a great question. I mean, first of all, because I can. That's always a good thing. Because learning, I really wanted to figure out this display thing, and I also really wanted to figure out how can I build an instrument that works for myself. Because that's kind of the important part. I built my own instrument. I can do whatever I want with it. It's not something where I need to wait for like a new update to a certain software to make it work better with my setup or something. And I have my own feedback process, so I sometimes talk to myself and say, hey, wouldn't it be cool if it would do this thing, and then it just implement it. And this actually does make a huge difference. And also, I just needed to build something for Live.js, otherwise it would be pointless. Yeah. And I would like to, I will show you a little demo of what this thing can do, and I would like to close with this quote. Who in here knows where this quote is from? There are actually 2 places, so anyone knows this? Yeah, no. It's in 2 pieces of music. Like one quotes the other. The other one is a little bit older than the other one. Interesting. I thought, like, last time I did this, there were a lot fewer people, so I thought maybe this time someone would get it. So the original quote is from Bob Marley. And let me get the song. I have no idea. I need to look that up. And then it's been quoted by. Come on. it's bigger than hip, hop, depress, right? Nice. So, and it actually starts with that exact line. One good thing about music, when it hits you, feel no pain. And I just love that. So let me give you a quick demo, and then I'm done. And I'm going to attempt to play this overhead so you can see it, and that's going to be really hard. So forgive me if it sounds terrible. Yeah, I mean, the script, I promised you to take a look at. So this is Ableton. I'm using this in the background just to generate the sounds because I didn't want to bring additional to this heavy beast. I didn't want to bring like 5 to 6 synthesizers to make sense. So this is all done in software right now. I can do both. This sounds better than external synthesizers because it's easier to build like this massive collection of synthesizers and effects. So yeah, this is what's going to generate the sound, but the whole sequencing, everything like you're going to see on comes from the other software, and yeah, it's going to be driven by this thing. Right. There you go. It's really hard. So let's hit play. That should be enough. Thank you. Yeah. Any questions? Oh, there, yeah, go ahead. Good point. The question was, is this open source? Let me answer that question.
Sorry.
Ah, wait a second. Did I? Ah, there you go. So yeah, that's the GitHub URL. So yeah, it is open source. If you want to take a look at it, it doesn't make any sense without an Ableton push right now. I really want to bring other controllers to this as well because the push is heavy to lug around. And it would be nice for conferences like this if I could just bring a smaller thing. Yeah. Yeah?
You have to code the module yourself for controlling the display, or is that something that's on NPM like always?
It's a thing that is on NPM like always, but I wrote it. So yeah. So there's there's libUSB, but I actually like implemented the whole data mangling to get it in the right format and stuff like that. Yeah. Yeah. Hey.
Thanks a lot. I was wondering, have you ever used this with your beatboxing?
Interesting question. Like, did I ever use this with my beatboxing? Not really. So Ableton does have some looping functions, and I really would like to try that out one time. But the thing is that I'm so nervous when I'm doing this live music stuff every time that I don't think that with an additional, I don't know, something like 10,000 hours of practicing, I would be confident enough to try to add my own voice to things. Yeah. Anyone else? Yeah. Thank you very much.